Okay, so here's problem number 11 from the worksheet from the textbook. We're going to have to develop a graph based upon two parts. The first part is the first derivative, which gives us our max and mins, and the second part is our second derivative, which gives us our changes in concavity. So for number 11, we have 3 points that are our critical numbers: x at -2, x at 1, x at 3. Now, we don't really care about whether or not the actual y values are, the f of x values, whatever you want to call it, for these problems. We just care that there is a what appears to be positive slope 0 to negative slope at -2, which means a maximum, a negative slope 0 to positive slope at 1, which means a minimum, and a positive slope 0 to negative slope at 3, which means a maximum. And it doesn't tell us either if it's an absolute or relative max. It just has to be a maximum. So for our graph, and I'm just going to sketch this by hand, I don't really have graph paper here. Here's my x-axis, here's my y-axis. I know I want, at -2, 1, and 3. So here's -1, here's -2, and then 1, 2, and 3. So I know at these three values here, I should have a max, a min, and another max. Now, the other part of this is at -1, there has to be some sort of change in concavity. And at -2, or +2, there also has to be a change in concavity. And it went from concave down to concave up to concave down. So I'm just going to start off and just make up some y values just to have some sort of max and min. So let's say this is 3 and this is -2. So at -2, I have a slope of 0. So at -2, I have a slope of 0, and it's got to go from positive slope to negative slope. So it'd probably be easiest just to put this like as, I don't know, something like -2, comma 2. And I know that it's going to go up into this and then down. And this is good for me also because at -2, it's supposed to be concave down, which it will because it's a maximum. That's our second derivative test. If you have a negative concavity and you have an inflection point, that means you actually have a max. Now, -1, though, is where it switches. So x equals -1, right here is when I'm going to switch from concave down to concave up. So I just need some sort of switch there. And again, it doesn't matter where it's at, but the graph needs to go from going down to start going kind of curving towards its back up. So I'm going to put it, I don't know, let's just put it right here at 0. So here's the graph. It comes down here. And then I have to start kind of just, I should do this probably with a pencil, but coming through and just, and we'll sketch a cleaner one afterwards. Now at 1 is my next minimum, which has a positive concavity, which it should, because the graph, again, for the second derivative, if you're a critical value and you have a positive second derivative, that means you have a minimum. So at 1 is my next minimum. I don't know, I'll just make it like right here. I've kind of made it pretty far down, so I need to go through here. So again, not pretty. We'll clean it up afterwards. And then at 2 is where I'm going to switch my next concavity to concave down. So right now I'm concave down, concave up, and then at 1 or 2 somewhere, again, it could be right here, I need to start switching to concave down to concave up to concave down. And then 3 needs to be a maximum, so I don't know, let's just make it go through there. Like that. So again, not the prettiest graph, but it would go something along the